Okay, folks, I'm going to do a quick overview of integration by parts. There should be a sequence of examples, but before I do that, I want to remind you where the formula for integration by parts comes from. So let's give that a shot. Sort of the rule or the trick to remembering where the formula comes from is to remember the product rule from differentiation in Calc 1. So let's go ahead and say we had a product of two functions. Let's say we had u of x being multiplied to v of x, and if we chose to take the derivative of that function, we would get, by the product rule, we'd get the first times the derivative of the second. I'll write that as x, plus the second, which was v of x, times the derivative of the first, du of x dx. Just to make it a little bit easier on the eyes, let's go ahead and we'll drop the of x's for these expressions. So that gives us that d dx of the product of u and v by the product rule is the first times the derivative of the second plus the second times the derivative of the first. Now we're going to go ahead and, because this function is understood to be differentiable, we just took its derivative, it's then necessarily continuous, so we can go ahead and integrate both sides. And so picking up with that, we have that the integral of d dx of u and v dx is equal to the integral of u dv dx dx plus the integral, going ahead and distributing the integral of the sum, v du dx dx. And so sort of formally manipulating these symbols, this isn't, really to do this you'd have to be a little more precise, but we could see that, okay, we could treat it as if those two expressions canceled. I guess over here, so again, that's sort of just a formal manipulation of the symbols, but it gives us the same answer as if we were really careful with our description. So we're left with this expression, the integral of u dv plus the integral of v du. And if you remember your integration by parts formula, we're already almost there. On the left-hand side, though, we've got the integral of the derivative. And so that, by the fundamental theorem of calculus, we're just left with the product of u and v is equal to the integral of u dv plus the integral of v du. All we need to do now to derive the integration by parts formula is to solve this for one of the integrals. And it's customary, just in the way people memorize the formula, to solve for that integral, although you could solve for either one, remembering that the choice of u and v are arbitrary as long as you're consistent. So we end up with the statement then that the integral of u dv is equal to uv minus the integral of v du, and that's the integration by parts formula. Some people remember it as ultraviolet voodoo. I'm not really sure how to make that whole mnemonic work. But anyway, this is our integration by parts formula, which you need to be familiar with for this class.